Thank you for joining me today. I'm going to be talking to you about long division. Okay, a couple things to remind you of here in the vocabulary is what a quotient is. You're going to need to know that because that's the answer to a division problem. Also, what the remainder is. A remainder is, of course, something that's left over after you divide. If a number doesn't go into another number evenly, then you're going to end up with a remainder. Then, of course, you have the dividend, the number under the division sign. As a reminder, you have a division sign that looks like this. You have a number here. That is your dividend. And you also have a number out here. That is what's below, the divisor, the number outside. All right. These can also be written in fraction form. The dividend, is always the numerator. So you're looking at 6. The divisor is always your denominator, over 3. So that's what that's referring to. Well, let's take a look at some examples here of long division. The first one we're going to look at is 5 divided into 6,854. So one thing to keep in mind when you're dividing in long division is your organization. It's very easy to get lost in these problems. So as we go through, I'll just point out some things to you along the way to help you keep organized. So the first thing you're going to want to look for is whether 5 can go into 6, the first number underneath the division sign. Well, if 5 is lower than 6, that means yes. You need to determine how many times. Well, 5 and 6 are pretty close. It's only going to go in one time. So because of that, we're going to write a 1 directly above 6 because that's the last value that we divided into. So now we do our multiplication. 1 times 5 is going to give us 5. And we can see the difference now in our division. 6 minus 5 is 1. So there was basically a one-digit difference between 6 and 5, which we already knew. So at that point, we're going to go ahead and bring down 8 as part of our process here. And I draw the little line there to try to, again, remind me that I've already brought that value down, so I don't get unorganized and accidentally bring it down more than once. So now we're going to determine how many times 5 can divide into 18. Now again, 5 doesn't go into 18 evenly, but it's lower than 18, so it will go in. We just need to figure out how many times. Well, we know it goes into 3 times because 3 times 5 is 15. 15 is the closest value that's under 18 that allows for that division. So we're going to write a 3 directly above the 8 because though we've brought that 8 down, it's still the last number that we've divided into. So 5 into 18 is going to go 3 times. 3 times 5 is 15. And we'll subtract again. 18 minus 15 is going to leave us with 3. Then at this point we bring down our 5, which is the next value. You can see I'm just working left to right underneath the division sign. And we're going to divide 5 into 35. Now lucky for us, 5 does go into 35. It goes in 7 times. 7 times 5 is 35. Do our subtraction and we get 0. So the last value, we go ahead and bring that down. That is 4. Now we run into a bit of an issue here because 5 doesn't go into 4. 4 is actually lower than 5, which means we need to hold the place up in our solution with a 0. Okay, we can't just stop there and say our answer is 137. It doesn't work that way. We've yet to divide all of the numbers. So at that point, we hold the place with a 0. 0 times 5 gives us 0. And we subtract to find that we do get a remainder of 4. Now again, based on or determined by your teacher, you can stop there a lot of times and just say that 1,370 remainder 4 is your solution. Now as you progress, your teacher may want you to rewrite that as a mixed number, or they may want you to continue it out as a decimal. But for right now, we're going to go ahead and leave it as a remainder. All right. Let's look at one more example here. A little bit longer of division, I suppose. We're dealing with a double-digit number outside, so we're going to divide 30 into 948,246. So the first thing we need to do, again, is figure out how many values in we need to go. So because 30 cannot go into 9, so we can either hold the place with a 0 and like so, and go ahead and multiply it out and then continue the division, or to save a bit of room, we can say, well, let's just go ahead and divide 30 into 94, okay, because that's the next available value that we can divide into, and that'll allow for the number to be large enough to divide into. So it makes it 94 then in this case. So 30 goes into 94. If you're not exactly sure, you may have to use a bit of multiplication, but in this case it actually goes in 3 times. You can use the estimation. You can take away the 0 from 30 and just know that 3 times 3 is 9, and then add a 0 on. That means it's 90. So 3 times 30 gives you 90. We're going to subtract there, which leaves us with 4. All right, go ahead and, just as you saw in the last problem, bring that next number down. So we're going to divide 30 into 48. How many times can 30 go into 48? Well, the second value, or second multiple of 30 would be 60. That puts us over. So that tells us that 30 can only go into 48 one time. So 1 times 30 is 30. So after looking at this, now we can see we subtract, and that's going to give us 8 minus 0 is 8, and 4 minus 3 is 1. The next value we need to bring down is the 2. So 30 into 182. Again, you can kind of use, if you take away the 0 from the 30, make it 3, you can kind of use some basic multiplication to help you out here. 3 times 5 is 15, or 150 if you add the 0 back in. 6 times 30 is 180, or 6 times 3 is 18. Add the 0 back in, that would give you 180. So you can use those little tricks to kind of help you along the way. So we know then, because 182 is larger than 180, that's the value we're going to go with. All right, so 6 times 30 is 180. When we subtract again, we're just left with 2 this time. Go ahead and bring down the 4. And a similar issue that we ran into on the last problem, where 30 doesn't actually go into 24. 24 is too small. So we have to, again, hold the place with a 0. Don't just stop. We hold the place with a 0 and subtract. And this time, we're going to be dividing into 246. All right. So at this point, 30 goes into 246. Again, use that process of estimation. 6 times 3 was 18, which gave us 180. We also have 7 times 3, which would be 21, or 210. If we go to 8 times 3, we get 24, or 240. So in this case, we're actually going to want to use 8, because 8 would give us 240. All right, and I'm just going to draw a line there, just to show off to the side here. If we subtract 246 minus 240, we get a remainder of 6. So we get quite a large number, but you can see how all the values are placed directly above the last digit that you divided into along the way. The key here is keeping everything as organized as possible so that you don't do any extra division that's not necessary. Number one, you don't bring down any numbers that you've already brought down before, and that ultimately you just can read the problem and figure out, if you get stuck along the way, where you may have made a mistake. Your final answer here would be 31,608, remainder 6. All right, so let's take a look at just a couple word problems here. There have been 508,324 fans that have attended the Braves games in the past 12 days. Approximately how many fans have been at each game? So again, we're taking the value 508. And let me give myself enough room here. So 508, 324. And we're dividing that, of course, into the past 12 days, or into 12. So 12 goes outside. 508 is our whole that we're dividing up into 12. So let's start our division. 12 goes into 50 how many times? Well, again, just use your basic multiplication or multiples to figure that out. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. You're trying to get as close as you can without going over. So it looks like 4. Since we're dividing 12 into 50, we will put that 4 above the last digit in what you divided into, which is the 0. So that's going to be 48 when we multiply that out. 50 minus 48 is 2. You can go ahead and bring down an 8. So now we'll do the same thing. 12 goes into 28 how many times? Well, it's only going to go in once because that's going to give us, or excuse me, twice, because that's going to give us 24. So 2 times 12 is 24. When you subtract there, you're going to end up with 4 left over. Go ahead and bring down your 3. How many times can 12 go into 43? Well, 4 would be too many because that gave us 48, so it's going to be 3. So 3 times 12 is 36. All right, and subtracting there, you might not know what 43 minus 36 is, so you have to do some borrowing here. 3 can't subtract 6 from 3, so we borrow, and that's going to give us 7. 13 minus 6, because that 3 would become a 13. So the next value we bring down is our 2. 12 goes into 72 how many times? Well, again, just go through your multiples or try multiplication. 4 times 12 was 48. 5 times 12, if you have to multiply it out to the side, you can do that. That's going to end up giving you 60. So it looks like we can go one more time. So it's actually going to be 6 times. 6 times 12 is 72. We get 0. We bring down a 4. Well, again, 12 can't go into 4, but we can't just not do anything about it. We have to hold that place with a 0. 12 doesn't go into 4, or it goes into 4 0 times, so hold the place with a 0, and then we'll multiply that out. Or excuse me, that's going to be 0, sorry. And then we subtract. And when you subtract 4 minus 0, you get your remainder of 4. Sorry, put that 0 back in, it came off. So you end up with an answer of 42,360. With the remainder of 4. Oops. All right. Let's look at one more example here. All right. Mr. Pryor spent $28,345 on his Jeep. He intends to pay for the Jeep in 28 equal monthly payments. How much will he pay per month? All right. So we're going to break up the total. Again, it's always the total divided by what you're breaking it up to. In this case, we're breaking it up in how many months? 28. So we're going to take that grand total, $28,345, and divide it by, I didn't give myself no room again. Move it down just a bit. 28,345 by 28. Right, so again, the reason why I know how to set it up like that is you're always going to put the grand total or whole of whatever you're looking at underneath the division sign. So now, it looks as though we can start by dividing 28 because it won't go into 2, so we're going to go ahead and push to the next value, which would be the 8. 28 goes into itself one time. So 1 times 28 is going to be 28, and we subtract and we get 0. We're going to bring down the 3, which is our next value. 28 cannot go into 3, so it goes in 0 times, so we hold that place with a 0 above the 3. When we multiply, we get 0. Subtract there, and you get 3. Bring down the next value, which is 4. Can 28 go into 34? Yep, one time. Only one time. So 1 times 28 is 28. We do a little subtraction there. Again, if you don't know what 34 minus 28 is, you need to go ahead and borrow, because 4 minus 8, you can't do that without borrowing, which is going to make the 4 a 14. 14 minus 8 is going to be 6. So go ahead and bring down the 5, the last value there. How many times does 28 go into 65? Again, if you're not sure what 28's multiples are, go off to the side and multiply. Let's find out what 28 times 2 is. That's going to be 2 times 8 is 16 plus 1, 2 times 2 is 4 plus 1, 56. So it looks like 2 times, because another time would be quite a bit too much. So 2 times 28 is 56. Now we're ready to subtract. 65 minus 56, if you're not sure what that is, you need to borrow. And you end up with 15 minus 6, which is going to be 9. And that's your remainder. So 1012 remainder 9 is going to be your final solution. All right, this has been a quick lesson on division, long division. Thank you for joining me.